just mentioned, these are some of the tools that come under the Qlik ecosystems, under their data platform tools that they have, which deal with different types of functions and different types of things that can be done on data, and including the ingestion and the streaming as well as the transformation part of it. So anything that deals with data, it comes under these Qlik data platform and category. And these are some of the tools that we'll be going through today. So first we'll be going through Qlik Replicate. I'll give you an overview. I'll tell you what it does, why do we use it, why is it so special, and I'll give you a demo of how hopefully we'll see it in action quickly, what it does and what all can be done through this tool. And then probably we'll go over to Qlik Compose as well. So firstly, Qlik Replicate. So by the name, you might have guessed that this tool is used to replicate datasets from one place to another, from one source system to, let's say, another destination or target. So what is Qlik Replicate? So Qlik Replicate is basically, if for a user, it is just a web UI based tool which manages different endpoint source connections and target connections. And basically you decide the strategy of how you want to replicate your data or ingest your data. So what we are talking about when we say ingestion or replication is there could be a scenario where you want your tables that are sitting in your operational database to get them into your staging databases. So in those scenarios, you might need to replicate those tables. Another scenario where you want any real-time changes that are happening on your source system to be applied at the same time in your staging or your target systems. So these are some of the scenarios where you would want a tool like Replicate to come in place and help you. So basically, as a whole, what this tool does is you'll have some source connections, you'll have some target connections, and you'll decide how you want to load data from source to destination. There could be different ways of how you want to load this data. There could be small transformations or small things like filtering of data that you might want to do on this stage. So basically, like I said, all these tools, Replicate, Compose, they all come under data platform part of Qlik, right, ecosystem. So some of the features might be shared throughout the tools because, for example, Replicate, you might see that is doing some of the transformation, minor transformations or filtering, but that isn't its primary purpose. Its primary purpose is to replicate datasets. Its USP is doing it in real time. What makes it unique is basically its architecture of how it works. So basically what they have done is, what Qlik has done is, the entire tool is architected in a way where it doesn't hold any driver of its own, and it uses the native drivers. So they're already relying on the database that you're choosing as your source or your target. They're relying on the native ODBC drivers that are available there, and they basically run on their system. So you are basically just giving the instructions in Replicate of how you want to replicate, and everything that happens is multi-thread, it is multitasked, it is multi-server. So you can copy multiple tables from multiple servers into multiple databases at the same time. Another thing that comes into place is the data volume. So one of the key features is for Replicate is that it can handle huge data volumes at speed that we have not known before. So for example, if you are loading 5 tables parallelly together from a database into, let's say, another source system, another target system altogether, you might get a throughput. With throughput is basically how many rows per second are transferred. So you might get a throughput of 40 to 50,000 rows per second. So if you add it up, it comes to 1.5 million rows per second that are being transferred from source to target. So one of the main features, apart from automation and everything, or the real time, is the amount of data that it pushes in really small amount of times. What does it consist of? When I say Qlik replicate, is basically for user, it is just a web UI screen which we will just see in a few minutes. And in the apart from that, from an admin point of view, you will have if it is on Windows, you'll have the Windows service running, or there's a server installed for this. But for the end user, it is, or for the developer, it is basically just a web UI interface where it is possible for them to give those instructions and manage their source and target connections. So, like we have already mentioned some of these, already discussed some of these features. So, I would say the main feature it does is that when it is implementing CDC, change data capture, it is basically reading those that DML information from the database logs. So it isn't touching your operational databases at all the time. You're basically touching your logs, and you might have you have different options available where you can choose to get a full load from a table, get incremental load, or capture the historical changes. So there are different ways given. There are different options that are available in Replicate, where you can decide if you want to get it from logs, or you want to do a batch or incremental. Another thing, another feature that really goes well is the parallel threading, because obviously it has a lot of competition when it comes to replication. If you guys are aware, there's MS SQL Server that does this, there's Oracle that does this, but again, they rely. You might face a lot of they rely on drivers, on native drivers, so you might face a lot of issues there. Again, apart from that, though the amount of data volume that Replicate pushes is not comparable to other tools. So these are some of the main features why we go for Replicate. As far as source and target systems are concerned, these are some of the sources and targets. Most of them are covered, as you can see, that you can use as your sources to replicate, and targets as well. So from an RDBMS point of view, from a cloud point of view, from a streaming point of view, most of the targets and the sources are covered. It's just that if you do want to use, for example, let's say you want to use Oracle. So if Replicate is not installed on the server that Oracle is installed on, you might need an instance or the ODBC driver for Oracle installed on the server where Replicate is installed. That's all the prerequisite it wants. So as far as that is sorted, and that too, I'm talking about the on-prem systems, cloud systems, that is not required. So most of your sources and targets are pretty much covered. Some of the use cases that why we use Replicate is first is because a lot of systems do require real-time data into their systems. So they want it to be continuously available, that real-time data stream. So Replicate provides a good platform to implement that. Then there's line of business workload offloading, where like we discussed, you can move a lot of data, and that is always available. So when I say highly available, your tables are not logged. If it's a RDBMS, they're not logged once, let's say, Replicate is replicating these tables. So there's no logs you have to worry about, as long as all the permissions are in place. It will easily move that data, and that data will be available at all times. Then again, right, because there are scenarios where you would want to pick up certain subset of data, quickly move it to a certain test environment, do some testing, or if let's say you're working on a bug, you can work on that particular data set. So you can quickly create those data sets using Replicate. You can quickly filter your data. You can quickly add minor transformations in it. So it basically helps you it enables you basically to make your data available across platforms, easily available. So these are some of the prerequisites of Replicate. So since it's a UI based application, so it is core based, and a lot of the processing is done depending on the core. So depending on what kind of system you're dealing with, these are the prerequisites you're looking at to set up your system. So some of the things, minor things that you might need to take care of is if there are any LOB columns, like large object columns. So if there are specific options for it in Replicate as well. So processing of them might depend on how your memory is configured. So apart from this, your console and services should be installed. You should have admin rights to start the services or stop the services, or this is just for setting it up. And once it is set up, I'll show you there are different ways to give accesses to different users and how different users can access the same server. Apart from that, like we've already mentioned, the native ODBC drivers should be available. We'll quickly see how Replicate works. We'll see it in action. So once Replicate is installed, you'll have the consoles. This is the Replicate service that will be installed. So as you can see, this is the console that Replicate provides for us to work on. You can see, so it is basically divided into two parts. So one is where you design your tasks and you monitor them, and the other is the server where you configure your server and scheduling jobs and other things like that. So we'll quickly go over tasks first. So let's say you want to create a task. You have a source system and there are a bunch of tables, and you want to replicate them to your target. So you'll create a task. So as you can see, there are different profiles given here. So these are depending on how you want to, what your use case is. So unidirectional is basically if you're moving your data just from one, it's one side from your source to target. Bidirectional is if you want to maintain the accuracy of data or the changes of data on both ends. So it's a two-way stream now, because anything that changes on the target will also be applied on the source as well. Log stream is something where it will read from the logs. There are certain prerequisites to all these profiles, because certain permissions, certain distribution channels, depending on the databases you're dealing with. Some databases you'll have to manually enable the logs, because I think most SQL servers are not distributing the logs, are not logging them on its own. Some of them might not. Some of the places you might not have the permissions to access these tables or the state that the database is in. Apart from that, there's Qlik cloud landing. So if your data is already residing somewhere in the Qlik environment, you can easily use this to integrate that. Apart from that, there are some task options. So going by the name, you can understand. So you can choose any one of the task options that you want to go with. So for example, full load means you want to copy the entire data from A to B, A being your source and B being your target. Apply changes means that you want to apply the changes that are happening on A on B as well. Store changes is you want to store those changes in B historical data, like we have sometimes we have slowly changing dimensions, or sometimes we just want to historically change it and not simply update a table. If a table is updated, we simply don't want to lose the initial value. So depending on the use cases, you'll decide what your new task is going to do. And let's say once you choose to create a task, you'll see it says drop a source endpoint here and drop a target endpoint here. So what endpoints is basically your source and target connections. So you'll have to create, let's say you're creating a source target here. You have different options what kind of source you could choose from. So as you can see from the list, So as you can see, there are 2 databases already there at the moment. So for example, you want to create, so you'll quickly choose SQL Server. You'll give what the details are. So in this case, it is localhost. You'll provide the details, username or password, or if however you're connecting from SSMS to the database, and then you'll get the details. I'll quickly show you. So once you provide this, it goes into your database. You can create one for target as well. So you can see there are different options there are more options for target once we click on target, there are more options for what kind of target it is going to be. So there are many endpoint connections you can choose from here. So once these connections are created, you can test them. Once you have decided, so if you look at this diagram, what you have done is, this is your source. We have decided what a source is. This in the task, when we were creating a task, we just saw those options: full load, or store changes, or apply changes. So since we chose full load, so this is the logo for that. If you choose apply changes as well, you'll see that here as well. Then you have the target. So once this is done, now you have told replicate where you want to pick the data from, and where you want to dump it, and how you want to the strategy you want to pick the data. But what data to pick, you'll have to go here and pick the tables. So it will give you a list of tables that are available in your source. You can simply select it, and if you click OK, you can see that table is available here now. If there are a bunch of tables, you can choose priority as well, which one do you want to load first, or which one do you want to be replicated first. So now you've told them, okay, from A source to B target, I want a full load for these tables in this load order. Apart from that, what all can you do? You can add a global rule, which is the minor transformations I was talking about. Like, you can rename a schema, rename a table, rename a column, add, drop. You can see these are just minor transformations that are available. Apart from that, there's filters where if how do you want to filter a particular table depending on a column, then you'll have to give a filter condition. Then you'll have to create an expression, something like this, where column is greater than 1920, then only that data will be replicated. So these minor transformations and filter options are available, as you can see. Apart from this, there are table settings. So these are specific to a table, which will give you some insights on the tables. So these tables are not loaded yet. These insights are coming from the source. So it will give you some insights. This is the same transformation that we saw from global rules. You can global will apply it to all the tables. These, if you add anything, add a column here or an expression here, this will be applied only to this table or this particular column. Similarly for filter condition as well, like we saw in global rules, that was being applied on a global level. If you double click on the table, it is the same as clicking on table settings, selecting and clicking on table settings. It will open this particular table setting, and you have these options. There are different options if you want to parallel load it. If you have partitions in your table, if you have date ranges and you want to use that, you can select how you want to parallelly load it. So you can see how easily they have allowed us to, even customize these parallel loadings and optimize our architecture, or optimize it, for best performance according to our systems. Then there's LOB column handling. We'll just go through once we look at the task settings. These are the same settings, but these are if you want to handle these columns on the table level. So these are done. You have decided your source, target, strategy. You have decided your table, how you want to load it. You've decided if you want to do any transformations on the global level or on the table level. And now there's something called task setting. So this is now your settings, how you want to run this replicate task basically. So as you can see, some of the settings are like how you want to replicate your LOB columns. So LOB columns, so for example, if the data type of your source system columns are for example, varchar, date, time, or anything else. So replicate knows how much is the maximum space that will be allocated and how much it will take. But in LOB columns, that isn't the case. A lot of memory will go to waste because the maximum space allocated is a lot. So you'll have to play around with these settings if there are LOB columns to if they're getting truncated. So usually they don't, but if your the character length is too long, you'll have to play with these settings to understand that. Then there are different settings you can understand simply by reading. Like if the target table already exists, what do? Do you want to drop and create? Do you want to truncate? Do you want to archive? Or you don't want to do anything? So these are just simple settings related to your strategy. What is the maximum number of tables? So like I said, optimization and tuning is basically is already set up, but you can tune it accordingly to whatever your amount of data set or whatever strategy you have decided. So if we had gone for apply processing, so these options would have been enabled, but these are simply, what if a DDL, as in what if a new column or is added on your source? How do you handle that? So you'll have to drop the target table and create it again. If it is truncated, what do you want to do if it is altered? So these are just different strategies and different. If there's history, store changes, processing, how do you want to store those changes? So whatever things you have decided, these are just settings according to that. How do you want your logging to happen, at what level? Then if there's any other character that is available that replicate cannot interpret, you can add those characters. And if there's a specific feature that is not available in Qlik, and it can be, then Qlik can provide a feature where you can add that here, and it will be available, something simple. So these are just some of the task settings that you can do. I'll just quickly show you a task that is already available. So these are some of the tables that are decided. So I'll just reload these tables again. So that was the designer that we were looking at. Now this is the monitor screen. So this is where you monitor your task. If you're running a task one time, as in a full load, like I'm running one time and it is not scheduled, you'll get these insights here, like what is the transfer count, which table, what is the transfer count, volume, what is the duration it took, what is the throughput. So you can see the throughput is very less here because the tables don't have any record, and for throughput for it, because there are so many small tables, it again has to go and get the metadata. So in case there's a huge table, and because that getting metadata is only a one-time activity in the start, so it probably takes like 3-4 seconds, 5 seconds to do that. And to copy that data, like I said, it gives you a throughput of 1.5 million per second, I've seen. So it depends on the configuration, depends on your systems, because right now we are getting from Postgres to MS SQL, so we are dealing with different databases. So there are a lot of factors that calculate this throughput. If you have dealt with any of the replication or even ETL tools, you might have come across this throughput. So this largely depends on the size of the data. So we don't have the amount of data here to show this throughput, but from my experience, I can tell that I've worked on huge data sets where the throughput was huge. So as you can see that the monitor screen is pretty much very clear. That gives you the total completed loading. If you click on these, it will give you whatever stats it's running right now. If there is any error, this is on the right side. This is where the errors will appear, the log messages you can see from here, or you can export. So these are just this is just the monitoring of one task, this task that I just ran. So this has basically copied like 24 tables from my source to destination. So this is how replicate task works. This is basically how a task runs from end to end. So you've seen, so all these are completed. So this task has stopped. So this task is complete. So anything related to tasks will appear here. If you click on tasks, you'll get these settings and designer and monitor settings, where you can see designer was where I was showing you how to design this task, and monitor is once we ran it, we saw how the progress of the task. Now we quickly go over to what server is. So that was all related to tasks. This is related to server. These are, now you've created your task. Now you just want to set up, these are the admin things related to it. You want to set up an SMTP server for it to send mails, notifications for your jobs that are running there. This is where you apply your licenses. This is where you want to, apply some global rules of error handling on how many times you want to retry if there's a data connection endpoint that is stopped, or how you want to log these errors. So these are also available on the task level, but this you're doing out on a server level. So these are the server logs. Then if there's any SFTP connections you have made, if there are any endpoint connections you have made, so if you add these here, they'll be available inside. So this is more on a server global level. Then there's any scheduled tasks that you can create to run daily or monthly or weekly. I'll quickly go over this. So you can either run a task, you can stop a task, or reload a task. So if it is a CDC, you might also decide when to run it or when to stop it. Then you have option for once, daily, weekly, monthly, and then which task you can select which all tasks. If you want all these tasks to run, you can decide, okay, run these daily at this time. So you can schedule these jobs. Then executed jobs is where you can see the history of these jobs, not the ones that are running on a daily basis, but if you run it once, if you schedule a job to run once, then you can see it in executed jobs. Otherwise, you'll have to see it in the logs. These are the user permissions that we were discussing earlier. So you can create users from here. You can create groups from here. Multiple users can access this same single replicate console server. You can decide what permissions to be given to them on an individual level. Then these are some admin related things like disk space and again features. So this all in all is what replicate is all about. This is how we replicate. We use replicate. We manage tasks. We schedule jobs to run tasks. We decide strategies on how to get this data. So all this was all we used to do it earlier manually. Like for example, incremental load. You would all these things you would decide manually. All these task settings are not nothing but things you would decide manually and try to implement on your own. So replicate is just automating it for you. It is making sure that everything is in place and all the best practices are already being taken care of. So this is replicate. I'll quickly go over to compose since we're short on time. So this was replication. So you have replicated your data, you've got it to your staging, you've done some minor transformation, but what about proper ETL? As in, what about proper transformation or proper aggregations or proper implementing of business rules and data quality checks and things like that? So this is where Compose comes in. So Compose is an ETL tool from the Qlik ecosystem, which again is a web-based UI tool. It basically runs like other tools on an integration server. So its equivalent would be on-prem would be SSIS or Informatica, Talent, Pentaho. On-prem would be not exactly, but ADF, where you would create pipelines and do transformations. So what Qlik Compose is basically why they've created this tool is because there are so many tools already present. But what they wanted to do is they've automated most of the data warehousing or data lake creation activities. So they have we'll see this in action, so you'll understand more clearly what I mean when I say automate data creation, data lake creation or data warehouse creation. They've automated most of it. They have tried to implement best practices So basically, you just bring a system to compose, or your data set that we had already, let's say, replicated from your operational database to a staging area. So you can pick up that staging data, into bring it into compose. You can do transformation, but everything will be taken care of. You just have to, again, like you saw in replicate, you just have to decide the strategy on how you want to do it, and most of the things will be replicated. Why is it unique? Like I just mentioned, because everything is automated. I'll even show you how it automates in the background, what it actually is doing. So everything in the background. So for example, even the replicate tasks. So a particular task, if you export it in the background, it is a JSON file. So these are all JSON files in the background. That is basically a set of instructions that is being implemented or processed on these servers. So what Compose has done is it is automating entire ETL code. It is applying all the best practices that are available, and it is reducing the manual coding task that usually a BI project takes. Because if you see an SDLC life cycle of a BI project, you'll have to gather your source data, then you'll have to model it, then you'll have to make sure that all the keys, indexes, all the datetime entities are in place. You'll have to then model it, then create a database, create a data warehouse, then make sure all the data warehouse practices are in place, SCDs are working, everything is in place, then all the mapping rules, lookups are in working. Then apart from that, you'll have to again go through the same process for creating data marts. So Compose automates most of these parts, obviously allowing you to customize it according to your needs. And again, what does it consist of? Again, just the integration server that we talked of and the web-based UI that we'll just see. So what are its main features? So like we've already discussed, you're optimizing it for either a model-driven or a data-driven data. It doesn't matter. It is simply, it is you are just giving instructions on how you want to implement your ETL. So there's real-time ingestion, there's automated ETL ingestion, and there's data mart. We'll see all these things in action in a few moments. Then there are some operational features that usually the ETL tools have, like monitoring and designing, and data profiling, quality assurance, notifications, and all. So everything that an ETL tool does, Compose pretty much take care of it. It is again depending on how you want to bring in your data, how you want to transform it, and how you want it to be published or given to downstream applications or reporting or to analytics in case of data lakes. So this Compose as a whole, its USP is again automating the entire process. So they are cutting down the time of development and testing to bare minimum. So some of the use cases are, again, now these Compose tasks can be associated with replicate tasks. So you can create a pipeline from your entire Qlik environment where all these things will be automated, and all these things will be, if you're scheduling a job, they'll obviously run in a timely manner. So there's very little use of, there's very little coding. Everything is automated, and all the best practices are taken care of. So again, this is a web-based UI interface. So the processing and all the aggregation and everything is happening on the integration server. So this is core-based, and depending on what kind of transformations or what kind of processing you're expecting, you will have to configure your system. So again, prerequisites will be things like the services, and these things should be installed in case of Windows. In case of Linux, the servers should be installed. and the console should be there, and admin access, and it, like I said, it is core based. So if you want to run a lot of things parallelly, concurrently, and improve performance, you can always add additional cores. So this is what the compose screen looks like. I have not created anything yet, so I'll quickly create now, so you can see how quickly a data warehouse can be implemented. So I have a database that has certain tables. So I've already created these tables, and these tables are already populated with certain data. So there are already keys available, and like you would expect in any operational system. So there are primary keys available, but that's it. It's simply a database with 4 to 5 tables, and with some records and some information available in it. So Compose, what you're looking at is just a project and the management screen. So what here was task and servers, is here it is project and the management screen. This deployment is just deployment of this project. So there's project and there's management. So once I click on new project, let's say I'm creating a project, it will tell you what kind of project do you want to create, what kind of environment it is. So you can decide, okay, this is my test environment. You can give a title, you can give the project a title. It will ask you, what do you want to create, a data warehouse or a data lake? I'll say a data warehouse. So you can see there are 4 blocks that I see now. The first one is databases, the second one is model, then data warehouses, and data marts. So again, we are in designer of this project now, like we were for the task. Similarly, for this project, we are in the designer now. So when we're creating a data warehouse, what we look at is, we will need an operational database that we have here, this one. So we have these tables. We'll need a database where we want to create our data warehouse. So let's say so it is quickly connecting to SQL Server to check out what all are the databases that are available here. Yeah, so these are the systems that are available here. So let's say I want my warehouse to be created in a new database. I'll just quickly create a database. So this is the compose database. So I'll just select this. This is where I want my data warehouse to be created. I'll just quickly tell what the schema and the data mart schema will be. You can create new schemas there if you want to. The connection is successful. So so now Compose knows where you want to create this data warehouse. Now you just have to tell them what is my operational source. So in our case, it is replicate. So I'll quickly create a source connection. Let's say source. So just for full load. You can select if it is designated by a database or a schema. I'll say schema. Then I'll say it is replicate, where you have to pick up the tables from. This is my error mart schema. Then you can, if you want, you can associate with the replicate task, where so these are the tasks that are available in our replicate. So I've already configured the replicate servers there. So these 2 tasks are available here. We've already ran the task, so we have already added the server. All you have to do is add the replicate server here, so it will associate your tasks to replicate. And then in case your data warehouse and your source database connections are different, and in our case we have created it in the same place. If it is different, you'll have to create the source database connection. So in our case it is different, so we'll quickly create OK. So you can see this part is done. So now we'll come to the modeling part. So once we come to the modeling part, we will have to discover what all tables are available in our landing. So we'll quickly see. So these are the tables that are available there. We'll select all of them. So as you can see, it is automatically generating a model on its own, where depending on whatever primary key, whatever relationships were defined here, foreign key, primary key relationships were defined here, it has already created mappings for it. It has created, I'll explain what these entities and everything is, but as you can see, it has already created all of this. So entities, as in how many tables did we select? We selected 5 tables. So these are the 5 tables that we selected. You can see the columns that are available in these tables. You can add new columns from here in these tables. So when I say add, you're not adding actually to the source system. Usually what you would do in an ETL tool is, like in a mapping, you would add a column, right? So this is where you want to add a column. So you can basically, whatever columns are available from source will come from there. Whatever expression you have given for the new column or wherever you want to populate it, it will go. Usually how we do an ETL. So this is where entities as in tables. Relationships is, so it has already, as you can see, created a model for you depending on what the foreign keys and keys of these tables were. It has already, if you select, it will show you the columns that are available in that table. So it is already giving you a tree view and a diagram of all the tables, and so it has already it has automatically created on its own this data model. Like all I had was these 5 tables and whatever I've done in front of you. So I've discovered them, and it has discovered these 5 tables. It has created these 4 relationships, and these attributes are nothing but the columns available in those tables. So all the columns, all those columns from all those 5 tables accumulated are being shown here. So entities are the tables, relationships are the relationships, and attributes are the columns. So display is nothing what we just saw, the picture, the diagram of this, where you see the model, data model of your data warehouse. Manage is if you want each of the tables, if you want to manage it. This is basically the logical model, and this is the physical model. Apart from this, some other settings available on the model level are this all we have done, and there's validate. You can always validate. We'll see. Okay, there's an error. We'll come back to it. Then there's options like add date and time entities. If they are not available in the tables, you can simply click on it and it will add date time entities. You can import your data models from Irwin. You can manage your attribute domains, which I just showed you by clicking here. You can use reusable transformations where you can create expressions, different expressions, and you can use it across these tables here itself. And then there are global mappings where you can create mappings of where your source systems and what columns should come. So in our case, we already had these tables. We already knew we had to pick these 5 tables. So we simply discovered it and got these 5 tables. So once we click on validate, it says it is a reserved name, since I think so this is ID, right? So it is one of the reserved names for Compose. So once we are creating this data warehouse, a lot of system tables are created from Compose on its behalf, where Compose will create system tables to manage basically all of this. So what I can do is I can quickly rename this, because ID1 is already used by Compose. So once I validated it, it's fine. Now so modeling part is done. Now I come to the data warehouse part. So I will simply click on create. So as you can see, again, it has created the SQL scripts required to execute everything that I've told, that I've mentioned in the previous one. So everything is created. All the data warehouse tables are created. Let's go quickly check here. If you see, these are the data warehouse tables that are created. These are the log tables, system tables that are created. These are the staging tables that are created. So Compose has already created all of these tables here. So if you see here, there is source. These are all the 5 tables. Now coming to the actual, T of the ETL transformations. So like every ETL tool has the mappings where you can select what data will go where. You can add the columns in the model, and then they'll appear in the mapping here, and then you can show where it wants to go, or you want to add a lookup to it, or you want to add an expression to it, or a data profiler, data quality. There are cleansing rules, validation rules that you can add. There's data profiling where it will give you stats on every table. There's auto mapping in case these are already auto mapped. In case they're not mapped, it will auto map them. There's change view but I feel this view is better to understand. And then there are null updates where again you're giving instruction on what happens when you're applying a null update. So things like this are done on a mapping level. Then on a warehouse task level, you'll have things like preload ETL where you can add some statements or SQL statements or a stored procedure or anything and execute it before doing the ETL. Then there's post loading ETL also. Then there's a single table ETL where you can define a specific ETL on a single table. There's multi-table ETL depending on what your requirement is. So once you have decided all this, if you want to handle duplicates as well, once you have decided all the mappings and all, you'll click on generate, which is basically it is generating all the tasks to handle all these instructions that you have given, whatever preloading ETL you have given, post loading, or these mapping instructions or anything you've given. As you can see, it has automated all of these tasks, and it is it has created instructions. So let's go back. You can see that 306 instructions were created for everything that we asked it to do. So we can validate it. So it is validated. Everything is done. Let's go to manage. Now everything. Let's say you would give your mappings. You would give everything. You would after giving all the instructions, you can if you click on task statements, it will simply show you all the 305 instructions that you have created, insert or delete or whatever it is doing. And if you run that task, you can see that. So these are the instructions that I was mentioning, like whatever SQL, if it is a DDL or whatever. So all these instructions in a normal BI project, you'd be doing manually, right? Even if these 5 tables I give you right now, you'll have to manually do all of this to implement the best practices and implement whatever we are doing right now. So all this has been automated and has been done. So data warehouse has been created. Then coming to the data marts. So again, I'll show you quickly. Let's say you'll have to decide what kind of data mart has to be created, if it is transactional, aggregated, state oriented. So this will largely depend on your use case. You can see some examples as well on what kind of use case you would go for. So you would already know what kind of data mart you're creating and what the use case it was. So accordingly, you'll select your fact type here. Then in this case, it is telling me to select a fact. So I'll select a fact. It has automatically selected the dimensions. As you can see, it tells me to select the transaction date. So all these things are there in place to implement best practices, to implement whatever, to automate all of it. So you can see it has created a star schema with a fact in between and 2 dimensions. It has now it has only created this data model for me. I'll have to create the table. So if I click on create tables again, it will create some tables here for data mart as well. If you see this TDMAR data marts, this was DWH was data warehouse. So I got these 3. So data mart is also created. So
how do you decide on what will be the hubs in a data warehouse? Do we have to sorry, I came in a bit late, but do we have to specify that how many hubs have to be created?
I was just showing how it was automated. So all we had was these 5 tables. So these only had these relationships in them, like primary key and foreign key. That's it. So compose automatically these 4 relationships it understood and automatically created this model, this diagram model for according to those relationships. We can obviously edit this. We can decide what kind of relationships or what kind of business keys, or if there is any other relationship we want to define. So this is all customizable. I was just quickly showing you how everything can be done if everything is in place. So we can obviously customize these relationships, and accordingly in the data marts itself also we can even once this data mart is created, we can add new dimensions. We can customize this star schema accordingly. There are a lot of things like pivoting and adding instructions that can be handled on data mart level also. So apart from, I would say,
and do you also create materialized views here on data marts, or
no?
And all that?
No. So views won't be created, but they can be picked. So when we were picking these entities, these tables, so we can pick up views as well. If there aren't available any, but if there are views, we can pick up them as well.
Okay. So data marts will still be at a granular level, right?
Right. Things you can add in preloading, like we have pre and post ETL. Those things can be handled here through SQL commands and some normal functions.
Okay.
Like you can write an insert statement, automate a script for insert statement for a particular column and things like that. So small things you can handle here through pre and post. Rest of them they are expecting that you have handled it while creating a data warehouse itself.
Okay. So
once
customize and okay. And in terms of the licensing model, this is annual subscription, is it?
I think it is annual subscription, but they do check it every 3 months. This license is updated. I mean, it is given out for a year, but every 3 months the license has to be validated, sort of.
Okay.
Right. So we were looking at this data mart. So I've decided what all should be there. So I'll simply generate. So again, these tasks, what they're doing is they're creating these data mart tables that we just saw. And once this is done, we'll validate if everything is right. And if you want, you can again see the task statements that will run. So these are all handled according to best practices. They're all according to they're optimized in the best way possible with whatever instructions you've given. So normally all these normal tasks or everything would be handled manually one by one. So right now I'm saying it to run to populate the data from your data warehouse to according to these instructions to your data marts. So that will simply pick up that data and it will insert in your data marts. So your data mart tables will have data as well now. So again, quickly, you just saw, I think within 15 minutes, you just saw implementation of a data warehouse and data marts for 5 tables, which even for these 5 tables, if I tell you to implement these with best practices and with everything that we did here, it would at least take you 2 to 3 days, like minimum. So as you can see, it is automating a lot of stuff. It is handling a lot of stuff on its own. You get a lot of insights while working on the data as well as data marts. You can create workflows to basically, so whatever you want to do. So this was our whatever data warehouse creation we did. This was our data mart creation, and then you can simply create a workflow like you would do in any ETL to run this after this parallel split, and how you want to, and then you can schedule it basically. So this you can add in this workflow, you can add replicate tasks as well if they are associated. You can add command tasks as well, where you can run your Python scripts or any other scripts that are compatible. So this is basically what Compose does. You just saw end-to-end implementation of let's say one data warehouse and one data mart, which is 5 tables. But this is all that a tool does. What all you would have different when it comes to implementation in a project would be the amount of instructions that are required, these post and pre-ETLs you'll have to fill in and take care of different things accordingly, and according to your requirement you'll have to basically customize your project. So coming back to a level, these are all the projects, and on a management level you have things like licensing and SMTP servers and handling the user permissions. Again, same settings that we saw in replicate. So this is basically I would say replicate and compose in action, and this basically covers a basic overview of both the tools. The quick demo, I wouldn't say it was quick, because even if I had to do for these 5 tables, I wouldn't have done anything different. So you can see how quick it was. So this was Compose, this was replicate. We saw a task, we created a task, we saw a task in action, how it was running, how quick it was. And again, for Compose, we saw how everything was created. These databases and these tables and all these system tables are created to take care of, like you can go into each and every table and see why the system table was created, what kind of information it is storing. So this is basically an overview of Compose and replicate.